Hello, ladies and gentlemen. My name is Mr. Bryson with Susquehanna Valley High School here in Conklin, New York, and we're doing Lesson 4 in Unit 4, pages 13 to 16. If you don't understand what I'm saying, just scan that QR code and you'll be able to see the original writer of these worksheets explain it to you. One of the skills you'll acquire in Common Core Algebra 1 was the ability to write equations of exponential functions if you had the information about the starting value and base, the multiplier of the growth of the constant. Now let's review some very basic problems. An exponential function of the form f evaluated at x equals a times b to the x is presented in the table below. Determine the values of a and b and explain your reasoning. Okay, so let's see here. This is really nice. Thank you very much for giving that to me. That means that f of 0 equals a times b to the x. Now, 5 equals a times b to the 0. What is anything to the 0 power? 1. So a times 1 is just a. So 5 equals a. So now let's figure out what b is. Okay, I'm going to grab another point. F of 1 equals 5, because that's what a is, times b to the first. Remember, we're plugging in 1 for x. Now, the function evaluated at 1 equals 15. So 15 equals 5 times b to the first. I'm going to divide both sides by 5. So 3 equals b to the first. Anything to the first is just itself. So b equals 3. Now we have to write the final equation. And there we go. Y equals, or f of x equals 5, which is substituting a and b. 5 times 3 to the x. Explanation? See my scribbles? That just gave you extra working space. Finding an exponential equation becomes much more challenging if you don't have the output values for input values that are increasingly by unit values, increasing by 1 at a time, especially if we don't start with the 0. Let's start with a basic problem. For example, an exponential function in the form of f of x equals a b to the x is shown, where f of 0 equals 8. Okay, that's nice. And f of 3 equals 1,000. Use the fact that f of 0 equals f of 8 to determine the value of a. Show your thinking. Okay, we just did it up there. So let's try it again. F of 0, which is just going to be 8, because it says f of 0 equals 8. And then we have a, b to the 0 power. So we know that b to the 0 equals 1. So just going to be a times 1. Well, gee, I mean, that's, so a equals 8. Divide both sides by 1. Use your answer from part A to find the fact that f of 3, the function evaluated at 3, is 1,000. Set up an equation to solve for b. You'll solve it in part C. So right now we're just going to set up the equation here. So now we have f of 3, which is just 1,000, equals, it tells us a is 8 and b to the x. 8, and we're finding b to the 3. We just set it up. Now, over here in C, it says solve. So what I'm going to do, I know it says use property of exponents. What I'm going to do is I'm going to divide both sides by 8. 1,000 divided by 8.
Stacy, Ruth, if you're in the building, please.
Let's try again. and then equals 8b cubed. Divide both sides by 8. So 1,000 divided by 8, 125. 125 equals b cubed. Now, this is where they say use, the properties of exponents. You should memorize, you should know that the cubed root of 125 is 5. We know the powers of 5. Determine the value of f of 2. So f of 2 equals a. What was a? 8. B. What was b? Times 5 and squared, because that's where the x goes. So the function value at 2 is 8 times 25. We do the order of operations, which is 200. 8 quarters, 200 pennies. If you have any questions, make sure you ask me. An exponential function exists such that f of 4, the function value at 4 is 3, and the function value of 6 is 48, which of the following must be the value of the bases. Okay, now this is a stinger. We don't have f of 0. There's no f of 0, so we're going to have to use a slightly different technique. We can't find the y-intercept like that. We have to do something else. So let's take a look at a table. So the x value is 4, and the y value is 3. We don't know what the x value of 5. We don't know what that is. That's a question mark. And the function, when we input 6, the answer is 48. Okay, now we got to think. Okay, here's the key to exponential functions. They increase by a factor of the base. So if we're going to go from one number to the next number, we're going to do 3 times b. And that equals the question mark right here. And then if we want to go from this to here, we have to multiply it by b again, times b. So what do I have? I have 3 times b times b. Has to equal 48, because we started with b, we multiplied it by, or we started with 3, we multiplied it by b, we multiplied it by b again. So 3b squared is 48. Divide both sides by 3. B squared equals 16. And so we know that b equals the positive or negative value of square root of 16, which is 4. Why doesn't it equal the negative value? Because this isn't, exponentials are not step functions. They're not flying back and forth between the positive values and negative values. It's just going to be positive 4. Let's take a look at the next page. Oh yeah. Now let's work with the most generic type of problem, just like with any two lines. Okay, I'm not quite sure where I was, so I'll pick up right here. And it just says plug in 2 for x and 36 for y. So 36 equals a b squared. Then it says do the same thing. 121.5 equals a b to the 5th. Now the problem here is that, again, we don't have these zeros. Okay, we don't have the y-intercepts. So it says divide these two equations. I had to read this several times. Divide the equations. Divide one equation by the other equation. Let me see. Which one am I going to do? Oh, why don't I do 121.5 equals a b to the 5th divided by. Now, this might be a little confusing to you. A b squared. So let's think for a second. Why in the world can this happen? I'm supposed to divide the left-hand side and right-hand side of the equation by the same thing. Shouldn't I be dividing both sides by 36 or both sides by a times b squared? Well, guess what? This is an extremely strong and dangerous statement here. Equals. This means wherever there's a 36, I can write a times b squared. Equals is very dangerous. Wherever I write 36, instead of writing 36, I can write ab squared. So that's what I did. Now let's do the arithmetic. A divided by A is nothing. It goes away. So I end up with 3.375, because that's what that is, equals b to the fifth divided by b squared. There seems to be some kind of rule. Oh yeah, 5 minus 2. So it's 3.375 equals, that's a subtraction sign, b cubed. Okay, now I still have to solve it for b. That means take the cubed root. So 3.375 raised to the 1/3, 1.5. Nice. Use your value from this problem to determine the value of A. Okay, so pick any equation, pick any point, I should say. Pick any point at all. So I picked the first point because they're nice numbers. 36 equals A times 1.5 squared. So 36 equals A times 2.25 divided by 2.25. And I get 16. So A equals 16. State the final equation. B equals 1.5. So the final equation, f of x equals A, 16, B, 1.5. I'm running out of room. I'm going to move it. To the x. There's the final equation. Let's now get some practice on some decreasing exponential functions. That means b is going to be less than 1 but greater than 0. Find the equation of the exponential functions on the graph below. Be careful in terms of your exponent manipulation. State your final answer in the form of a equals b to the x. So here's a point, and here's a point. We have 2 points. We don't know the y-intercept. We're going to do exactly what we did before. And there we go. Those are the steps. Hit pause, because I'm going to skip ahead. So write it down. Step number 1. Oh my gosh, if you don't have any room, grab a scrap piece of paper really quick. I know, I'm sorry, we don't have room. If I didn't have room to write it down, I had to move it out of the way. Neither do you. So, step number 1, set up the 2 equations. 128 equals a, b to the negative 2. Then the other equation, 1/2 equals a, b to the 2. Because we take the x values and put it in for the exponents, we take the y values and put it in for f of x. Now, divide the 2 equations. Hey, believe me, it's a lot easier dividing by 1/2 than it is to divide by 128. 128 divided by 1/2, believe it or not, is 256 equals. The a's cancel. Now, this is going to be b to the negative 4. What? Yes, the top, the numerator, divided by the denominator. So this was negative 2 minus 2. Okay, now, how do you do this? Well, the way that we do it is, remember the property of exponents. It's 1 over 256 equals 1 over b to the 4th. Now, I told you about that little trick up the sleeve about using logs. Okay, well, now we know that 256 equals b to the 4th. I can just reciprocate both of them. So what number to the fourth equals 256? Let me see. It's even. 2, 4, 8, 16, 32. Nope. Let's try 4. 4, 16, 64, 256. Bingo. Or we could have used our calculator. So B equals 4. We just solved for the base. Now write standard form of the equation, substituting in any point. Pick a point. I'm going to pick the positive value of a point. You can use negative numbers if you want. So I'm going to have f of x equals b, which is 4a. Sorry. Let's try again. A, and then b is 4 to the x. I'm going to use the positive values. So 2 equals a to the 1/2. Whew, that's easy because why am I doing that? I'm just trying to go fast. Sorry about that. Slow down, Mr. Bryce. 4 to the 1/2 is 2. So 2 equals a times 2. Divide both sides by 2. Divide both sides by 2. 1 equals a. Write the equation down. F of x equals, what is a? A is 1. What is b? B is 4 to the x. I just wanted to run through it. Okay. Exercise 6, a bacterial colony is growing at an exponential rate. It's known that after 4 hours, its population is 98. 4, 98. And after 9 hours, it's 189. 9, 189. Why did I put time? Not because it appeared first. Time is always independent. What'd you say? I said time is always independent. You can't slow it down. You can't speed it up. Time, independent, is always the x. Determine an equation in y equals ax, a times b to the x form. That miles the population, y is a function of the number of hours x. At the percent rate, the population is growing per hour. Good, the units are still in hours. We don't have any problem with that. It's exactly like the previous question. Step number 1, set up the two equations. Okay, so again, remember our equation is f of x equals a b to the x. So 98, f of x is the same as y, equals a b to the 4th. And 9 equals 189 equals ab to the 9th. We can divide these. Let's see what we get. So I divided 189 by 98, and I divided 98 by 189. And then I decided, well, this is a growth. It's getting bigger after time goes on. So I'm going to do 189 divided by 98 and use that. So we don't have very much room. So I'm going to do 1.92857 when I divided the two. Equals, remember, a divided by a cancels out, but b to the 9th divided by b to the 4th is b to the 5th. Now, since this is still in my calculator, I'm going to take that to the 1/5 power. It automatically pops up with the answer, 1 divided by 5, and it tells me 1.14. It says percent. So here, when I take the 5th root of it, let's see if I rounded in correctly. 1.14037. Good. It's rounded well. 1.140. It says what percent? Well, You may remember from 5th grade that this formula right here is exponential growth. A is the starting amount. We have 1 plus percent over 100 raised to the x. That's an exponential equation. So here, A times 1.140, because that's what B is, to the x. So here, we're 1 off. Oh, see, we're 1 too big, so all we got to do is take 1 away. The percent is 14%, because 0.14 goes to 14%. Per means per 100. They're 14 hundredths, so there's 14%. Whoo-wee. So let's change up our homework assignment for tonight. We're just going to do the next page, number 1. Then we'll work on number 2 tomorrow in class. So do number 1 tonight. I'll see you later if you have any questions.